Hello fellow nerds, welcome back to our channel, and in today's video we will continue on where we ended on the previous video on vectors. We are going to talk about we'll get into solving some examples so we can fully understand the concept we had learned in the previous video. So if you did not watch that previous video, it would be much more better if you did, so you can quickly understand the concepts and so you can actually move together. All right, so all right, we did question 1 in the previous video, so we just get into the second question and explore some more concept that we had learned earlier. All right, so okay, so question 2, calculate the x component and the y component of the vector with magnitude 24 meters and direction 56 degrees. All right, okay, so the x component, so what do we have? So your data is we have magnitude of 24 meters, right? Direction, which is the angle 56 degrees, right? What else? Okay, we are taught to do what? Find the x component and the y component. Okay. All right, so in the previous video we had learned on how to find the x and y components, right? It was simple trigonometry, opposite, adjacent, hypotenuse, right? So it's vy, so it's vx. All right, so katoa. All right, this is a quick review for those that did not check out that other video. So sine theta, opposite was vy, hypotenuse. So vy was hypotenuse, which is the typical vector, the resultant vector there, sine theta. The vx was going to be v cos theta. Okay, all right, so we've been taught to find x component and y component. All right, like we said in the previous video, the angle denotes a direction, but in the previous video, in the previous question, we had 45 degrees above the x-axis, above the positive x-axis. All right, how then do we know where this 56 degrees is coming from? All right, so if this is the actual direction that has been finalized in the question, it does mean one thing: this is the true direction, right? Now, what is the true direction? Okay, true direction according to vectors, it should be the angle that is driven from the positive x-axis. So the direction is always coming from the positive x-axis. Now this should be very important to take note. Always from the positive x-axis. If you've been given an angle from the negative x-axis, you have to find ways of getting the positive angle of that negative x-axis angle. The angle you should always consider for vector should be the one that is coming from the positive x-axis. Very, very important. All right, we will look at how important this is in the following question, but for now we've been taught to just find the components. All right, so vector component of x is v cos theta. Now v was the magnitude of the resultant, which is 24 meters. Cos theta was the angle 56 degrees, is equal to vx. So vx is equal to, all right, so you are going to use a calculator. All right, so we have, so you use your calculator, you say cos 56 degrees multiplied by 24 will give you 13.4, right? This should give you 13.4 meters. Okay, that's basically it. For the y, you do the same. Vy is v sine theta, 24 sine 56 degrees. Vy component in v, you'll have sine 56 degrees multiplied by 24, that is 19.89. so we just say 19.9 meters. That's basically it for that question. Simple stuff when it comes to finding the components of these vectors. All right, let's look at the next question. A vector A has components ax. Okay, so we have the vector component of A in the x-axis is -5 meters, and y is 9 meters. So all right, so the x is -5, the y is 9. Find the magnitude and the direction of the vector. All right, so okay, so we've been told ax is equal to -5, ay is equal to 9. We've been told to find the magnitude, right? The magnitude of vector A, right? And its direction. The magnitude, we've said we have to find the number in question, the scalar quantity, the scalar item of this vector. The direction, we know what we are talking about. We have to find the what? The angle. All right. So how do you find the magnitude of a vector? Like we said, these formulas were coming from a trigonometrical function where you have hypotenuse, we have adjacent, we have opposite, right? This is Vy, Vx. And from this, we do know that for you to find hypotenuse, which is the magnitude of the vector, you are going to say hypotenuse squared is equal to what? Opposite squared plus adjacent squared, right? Square root. So hypotenuse will be the square root of opposite squared plus adjacent squared. Hypotenuse is the velocity, in fact, the vector of A. The square root. Opposite is vector component y, right? Squared plus adjacent is vector component x squared. And we know what these components are. So the square root of y is 9 squared plus this is -5 squared. All right, and so we have, this is what? This is 81 plus 25. Okay, so 81 plus 25 should give you that 106. The square root of 106 should be 10.29. So we'll just say this is going to be equal to 10.3 meters. Okay, that is our magnitude. All right, our direction, we looked at direction. We had done opposite over hypotenuse. So we remember that opposite was what? This is tan theta, right? So opposite is Vy, adjacent is Vx. All right, so theta is going to be tan -1 that. What is your y? 9. What is your x? Your x is -5. Okay, what does this tell us? This tells us that this angle, so when we graphically show this angle, right, this angle, -5 is on this end, right, 9 is on this end. This angle is in this section. All right, now if you guys remember quadrants, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. If an angle lies in quadrant 2, means you'll have to come and subtract that angle from 1/8, right? If the angle, okay, we'll get into these other quadrants when we look at questions that have to do with quadrants in this section. Okay, so questions in these quadrants. Okay, so 180 minus the angle in question, the angle that we'll find. All right, so the number down there can be put in modulus form, because the negative only suggests that your angle is not coming from a positive x, because this is an x value, right? This is an x value. So an x value should come from the positive x-axis. That's what we said. The angle should come from the positive x-axis. And so if your x-axis is coming from the negative, that means that is not the angle in question. That is why this formula only works. The angle that you get directly only works for values that are in quadrant 1 and quadrant 4, where you have negative 90 degrees to 90 degrees. Any angle past this will have to follow the rules of these individual quadrants. But let's focus on the negative, on the x. If the x has a negative, it means it is on this other end, and that means we'll have to come and subtract the angle that we'll find from 180 degrees. Why? Because the angle is not coming from the positive x-axis, it is coming from the negative x-axis. So again, the negative only suggests the angle is coming from the negative x-axis if it is on the value that is on the x-axis. All right, I digress. Okay, let's continue. Okay, so again, the modulus will literally cancel out the negative, right? So we literally have theta is equal to tan inverse, okay, 9 all over 5. That is basically what we have now. So 9 divided by 5 is 1.8. Then on your calculator you press shift, then tan, then you close brackets, your answer, then you equal sign, then the angle will be 60.945. we just said 60.9 degrees, but we said this is not the original angle we're looking for. This is not the correct angle we're looking for. Why? Because this angle is coming from a negative x-axis, but we need an angle coming from a positive x-axis. So let's imagine, like we said, this angle is coming from this is your negative, this is your positive. This angle is coming from your negative x-axis, making a 60.9 degrees. But we want this angle that is coming from the positive x-axis. And that is the reason why an angle in this quadrant you subtract from 180, because from the positive x-axis to the other end, this whole thing makes 180 degrees. So if you are going to find this portion, and if this portion is 60.9, mathematically speaking, 60.9 plus x should give you 180 degrees, because this whole thing is 180 degrees. And that basically will mean 180 degrees minus 60.9 degrees should give you that x, right? If we say 60.9 plus x should give you what? 180 degrees. So x is going to be 180 degrees minus 60.9. This is basically what we've just done. All right. So 180 minus 60.9 gives you 180 minus 60.9 gives you what? Gives you 119.1 degrees. Okay, that is basically our angle. All right, so how then do we write our final answer? Okay, so our final answer, we know this magnitude is an angle this side, right? And the -5 is this side. All right, so this is the resultant with the magnitude that we have, which was 10.3 meters. Okay, so this is 10.3 meters. Okay, then the angle it has made is 60.9, which is not one we're considering. Again, you should remember that, very important. Okay, so the angle we are considering is 19.1 degrees. Okay, so how we write this is the resultant vector, sorry. Okay, the resultant vector is equal to 10.3 meters, comma 119.1 degrees above the positive x, or 119.1 119.1 degrees, 119.1 degrees from the positive x-axis or above the positive x-axis. You can write it as this as your final answer, or you can use the compass way of writing your answer, right? Okay, so we know compass wise, a compass is north, south, west, east. So is our graph, right? A graph is in that type of order. All right, so when you look at this vector, when you look at the compass and look at this vector, it is lying in this space, right, which is the northwest. So some can answer this as the angle we have is this whole angle, this side, right? This whole angle is 119.1 degrees, all right? But some can use the compass to write its direction. This is north, this is west. This is north, this is west, right? So this angle here, this angle here, you can denote it as, this is your north, right? So this is west of north. The north, the west part of north, this is its angle. So you can find this small angle and say the resultant vector 10.3 is situated west of north, which would just signify this portion from north. West of north will start to move this side till we make the small angle here. That should denote a direction. But then a physicist will probably know that the angle, the total angle that should be considered is one coming from the positive x-axis. So if the compass idea does not work for you, you can stick to just saying above the positive x-axis or from the positive x-axis. So for that would want a compass way of arrangement, you can say V, resultant vector V, is equal to 10.3 meters. Okay, so let's find this small angle, right? This whole thing is 119.1 degrees, 119.1 degrees. This is 90 degrees, so we can subtract 90 degrees to find that small angle, right? That's just mathematics. So that minus 90 degrees should give you what? 29.1 degrees west of north, and you can put it that way. Okay, all right, that's basically how you answer a vector question, magnitude and the direction. You should never forget to put direction when you find a vector quantity. All right, well, I guess in today's video we'll end here, and we will look at some more examples if there's need. More examples, probably for more understanding, right? With physics you have to encounter more questions, analyze more of these scenarios, and you should be good to go. So for more understanding, repetition increases understanding. Okay, so we will look at some of the examples that we've not tackled yet, and see how best we can improve our understanding of the topic. But for now, we will end here. Thank you so much. Laters.